Yes, this time around, I want us to treat construction and locus. I will begin with copying of an angle. To copy an angle, suppose we are given angle XOY, XOY. We want to copy angle XOY. I don't need to bother my head about the size of the angle. All I know is that I am given angle XOY and I'm asked to copy it by construction. And to copy it by construction, I will draw a line which I will call O prime X prime. O prime S prime. You draw this line. And then you come back to this given angle and using O as your center. Using O as center, of course, you know this is your compasses. Compasses. Using O as center and a convenient radius, you describe an arc to cut OY and OX at P and Q. You come to this O prime and use the same radius, and of course you describe an arc to cut O prime S prime at P prime. Now you come and measure PQ. Measure PQ. With PQ as radius, you now come to this P prime and describe an arc. To cut the first arc, at this point you will now call Q prime. Now take note of what I said. You will measure the distance PQ from the given angle. Use that as your radius. And with this P prime as your center, you describe an arc, which will cut the first arc at the point you are calling Q prime. Join O prime, Q prime. You join O prime, Q prime. Angle O prime, P prime, Q prime is the same as OPQ. All you need to do is you use your protractor to confirm it. You measure this angle. You come and measure this one. It's exactly the same. So we have been able to copy this angle by going through this process. Now, number two, to bisect an angle. To bisect an angle, we are given angle ABC. The angle is at A. Angle CAB, if you like. Angle CAB or BAC. We want to construct the bisector of angle BAC. This is how we do it. With A as center, you describe arcs to cut AC and BC at P and Q. Arc this way, arc that way. To cut AC and BC at P and Q. Now, with P and Q as centers, you describe arc this way, go to Q, describe with the same radius, you describe another arc, and the two arcs we cut at the point R join AR. AR is the bisector of angle BAC. If you measure the angles, you will see that they are the same, they are equal. That is how to construct the bisector of an angle. I want to go through it again. With A as center and a convenient radius. You see, when we talk about convenient radius, it's just that if you use A as center and begin to use a small radius like this, or you put it outside the lines, you won't get any good result. So you have to determine a convenient radius. So with A as center and a convenient radius, describe an arc to cut AC, cut AB at P and Q. They're using P and Q as centers. And with the same radius, we describe an arc this way, another arc that way, and the two arcs we cut at the point and join AR. AR is the bisector of angle BAC. Now, like I said here, so AR is the the bisector of an angle is also the locus of points which are equidistant from the lines that form the angle. In other words, AR, every point along AR is equidistant from AC and AB. Every point you take along AR, that point is at equal distance from AC and AB. And so, that bisector becomes the locus of points which are equidistant from AB and AC, the two lines that form the angle. So, when you construct the bisector of an angle, you have at the same time constructed the locus of points equidistant from the two lines that form the angle. Now we are going to make use of this angle bisector to construct what we call in circle. Now we are going to construct an in circle. We are constructing an in circle. Now you draw a triangle ABC. Triangle ABC. You draw triangle ABC. Now you construct the bisectors of any two of the triangles. Any two. So with B as center and a convenient radius, we describe an arc this way, arc that way. Come to the point of intersection here, describe another arc, come here, another arc. We now get the bisector of angle ABC. Going to C, we again construct the bisector of angle C. You can see the two bisectors. The bisector of angle ABC, the bisector of angle ACB. The two bisectors intersect at the point O. Now, using O as your center, using O as your center, and a radius that will touch any of the sides, touching, using O as center and radius that touches any of the sides, you begin to construct a circle. You will discover that circle touches the three sides, and that circle we call in circle. What it means is that using the idea of angle bisectors, you can construct an in circle. That is a circle that touches the three sides of a triangle. That's what we call in circle. A circle which touches the three sides are tangential, if you like. The three sides are tangential to the circle. You call it in circle. So we use the idea of an angle bisector to construct the in circle of a triangle. In our next meeting, we shall see some other forms of construction and locus. Thank you and God bless you.